In this video, we're going to take up the drawings of Bohr-Rutherford diagrams for the ions of magnesium and fluorine. So first, you draw the regular. We're going to start with magnesium. We're going to draw the Bohr-Rutherford diagram for magnesium. If you look in your periodic table, we know that magnesium, Mg, has an atomic number of 12 and a mass number of about 24. So to quickly review the number of protons that magnesium would have, the atomic number is 12, so 12 protons. And because we're drawing the neutral one right now, it would have 12 electrons as well. And for the neutrons, you just do the mass minus the atomic number, and you get 12 neutrons. So when you're drawing your Bohr-Rutherford diagram, you would have 12 protons in the nucleus. That should be a P. And 12 neutrons in the nucleus. Then you would place your electrons, so 2 on the first shell, 8 on the second shell, because that's full now. And then you only have 2 more to place, so 1 and 2. So magnesium is in the second group. So it has 2 valence electrons that we saw. So these are the 2 valence electrons here. So it's going to lose 2. It's easier to lose 2 than it is to gain 6. So when we draw the ion out, we'll still have the same number of protons, 12 protons. We'll still have the same number of neutrons, 12 neutrons. But now we're going to have fewer electrons. We're going to have our electrons in the first shell and the second shell, but the third shell is gone because we lost those 2 electrons. So because we lost those 2 electrons, our charge is now 2 plus. So this was regular magnesium here, the count for regular magnesium. But now we have magnesium 2 plus. Magnesium 2 plus has the same number of protons as magnesium without a charge, 12 protons. Same number of neutrons because those don't change either. But now 2 plus has 10 electrons because it lost 2 electrons. That makes sense because there's 2 more positive charges than negative charges, so it's 2 plus. And so that's how we determined the charge of magnesium. Magnesium lost 2 electrons to become like the noble gas neon. Because if you think about it, magnesium had 12 electrons. When it lost 2, it has 10 electrons. What else has 10 electrons? Neon. So it became like neon. The next one is fluorine. So fluorine, if you look in your periodic table, looks like this. Fluorine, atomic number of 9, and I believe mass number of 19 approximately. Let's take a look. 19 and atomic number 9. You can take a look at the legend here. It tells you what each number means. So atomic number and atomic mass or mass number. So that means that fluorine, just regular fluorine, has 9 protons, 9 electrons, and 19 minus 9, 10 neutrons. That's how you find their subatomic particles, the protons, neutrons, and electrons. So in the nucleus, we're going to draw the protons and neutrons. So we have 9 protons, 10 neutrons, and then we're going to place our electrons. We have 9 to place, so 2 on the first shell, and then 7 on the last shell. So that's 5, 6, and 7. You add them single first, then pair them after. And so what you'll notice is fluorine could either lose all 7 or gain 1. It's easier to gain the 1, right, than lose 7 because you're more than halfway to 8. So we're going to gain the 1. We're going to keep the same number of protons. We're going to keep the same number of neutrons. We're going to keep our shells because we're not losing anything. We're in fact gaining. Now you could draw your gained electron as an X or just as a dot as well. I'll put an X just so you can see I added 1. And because you added 1, you become negative by 1, negative 1. So what you have is F 1 minus. Your number of protons is the same. Your neutrons are the same. But you have an extra electron. 10 electrons now instead of 9. So you have 1 more negative than positive charge, which makes you 1 minus. So that's a fluoride ion. You don't always have to draw them out to figure out the charge. You could just look again at the group number, group 7. So 7 valence electrons, going to gain 1, negative 1. with magnesium. 2 valence electrons, going to lose 2, so plus 2. And as you can see, fluorine gained 1 electron to become like neon. Right? Non-metal gained to become like neon. When it gained 1 electron, it had 9 before, now it has 10 like neon. So that was taking up the drawings for Bohr-Rutherford diagram for the 2 examples there. We're going to do our next concept called the ionic notation. So we'll go over the concept and do some practice problems there because we're still on the topic of ions. So one way to represent elements is by writing out the atomic notation. So if I had sodium and I want to write out its atomic notation, I would put its mass on top, on the top left, and its atomic number on the bottom left. And the atomic number represents the number of protons and neutrons, or electrons, sorry, and the mass number represents the mass of the atom, and you can find the neutrons with that. So for example, if I want to find the number of protons in sodium, I'd look at the atomic number, I'd have 11 protons. I'd also have 11 electrons because they're the same in this sodium here that I've drawn. And then for neutrons, I would do 23 minus 11 gives you 12 neutrons. Now, what we have over here, this one, is the ionic notation. So this here would be the atomic notation, meaning when it's not charged. There's no charge on it, it's just the regular sodium. But here we have it when it's charged. So if I were to give you the ionic notation, like this, and I asked you to find the number of protons, electrons, neutrons, here's how you would do it. So the number of protons and neutrons are the same. Same as before when you find them. For atomic number, that would give you a number of protons, you'd have 11. And for neutrons, you do 23 minus 11, gives you 12. Now normally, if there's no charge, your electrons and protons will be equal. But because we put a positive 1 here, what that means is that now you have fewer electrons. Because it's positive 1, it means you have 1 less electron than you normally have. So normally you would have 11, but because you're positive 1, it means you lost 1 electron. So now you have 10 electrons instead. So that's the ionic notation. If you want to know the number of electrons based on the charge, you have to find the regular amount, which would be your atomic number, and then add or subtract depending on what the charge is. So let's try a few examples here. Let's look at the ion notation for bromine ion over here. So you can pause the video and try it yourself. If you look at the bromine ion, number of protons would be simply 35. And number of neutrons would be your 80 minus 35, which would be 45 neutrons. Now for electrons, normally that would be 35. But notice you have a minus 1 charge. So that means you have 1 more electron that you normally have. So you're going to add 1 more electron to make it 36 electrons because this is a bromide ion with a negative charge. So that would be the process to calculate the protons, neutrons, and electrons from the ionic notation. Now in this case here, let's take a look at the next example. We have to try to figure out what element we have so we can draw the notation out. So to figure out the element you have, you look at something that never changes, which is the proton number. So there's 13 protons, and you go in your periodic table and you find the element that has 13 protons, which is aluminum. So aluminum has 13 protons, and then it has a mass of 26.98, which you can round to 27. So we're going to have aluminum. We're going to put 27 on top for the mass and 13 for the atomic number. Now, we have to see if this is charged aluminum or not. If this is not charged aluminum, the number of electrons should also be 13. But notice that it's not. Normally you would have 13, but we don't. We have 10 instead. That means we lost 3 electrons. That means this is the charged aluminum. Aluminum is in group 13. So it has 3 valence electrons, it would lose 3, so that means that it would become positive 3. So we could write 3 plus up here to show that ionic notation. And so in this video, we took up the examples of the Bohr-Rutherford diagrams for the magnesium and fluorine ions. We also looked at ionic notations. We'll finish up by writing the ionic notations for fluorine and magnesium ions. So if you want to write the ionic notation for fluorine, you would normally do the mass is 19 here. The atomic number is 9, right? 9. And you look at the charge of the ion, 1 minus. For regular fluorine, it would simply be 19 and 9. That's when there was no electron gained. If you want to draw the atomic notation for magnesium, you would have the mass is 24 and the atomic number is 12. If you want to do the ionic notation, 24 and 12 stay the same, but then you have to put the charge of 2 plus up here to indicate that 2 electrons were lost. So we saw and reviewed atomic notation, and then we turned it into ionic notation from there. You'll see here there's some optional concepts called isoelectronic. You can do an independent study of that. There will be a video for you to look over if you'd like to go over what it means to be isoelectronic. But so far all the videos you've seen are all you need for the required material for this segment of the course.